welcome to the last session on this track for PyData Global 2024. I'd like to welcome Adarsh Namala to give his talk scaling outside the warehouse using DuckDB in Python. Thank you so much for coming, and I'll hand it off to him. Thank you so much.
Hey everyone, thank you for joining the session. Let me share my screen. So I'm Adarsh, and this is scaling outside the warehouse using DuckDB and Python. Main overview of the talk, a quick introduction for DuckDB. It's not going to be detailed. If you are already familiar with DuckDB, I'm preaching to the choir. If not, my motivation is to introduce you enough so that you're incentivized to check it out. It's a great tool to have in your toolkit. Talk also a little bit about DuckDB in Python. The main topics are going to be alternatives to processing large-scale data outside the warehouse. Ideal for massively parallel processing tasks. Think about like daily, monthly, or hourly tasks that you want to process in parallel. We did a use case in my company where we had daily logs that we had to process on a monthly basis, and we did this for a year. In Snowflake, that cost us about $1,200. When we use DuckDB with Coiled using on-demand EC2 instance, it was about $104. And when we use Spot instance, it further reduced to $46. So clearly you can see a 92 to 96% reduction in cost. A little bit about me. I've been in the data space since 2014. I'm currently a senior data scientist at A&E Networks. Started off with R Python, moved to Databricks, played around with cuDF and Blazing SQL, came across DuckDB in 2020 and was blown away with it. Life has not been the same since then. In the interest of time, I'll give an overview during the demo. So let me just go to the demo. I've pasted the link to the code in the chat and the slides too. There are 3 scripts in this. One is the demo script that I'll be going over. Then there's Lambda function script. I'll go over that too. And the utility script, which has different helper functions that I'll be giving you a quick overview about. So let's go over the main demo. So these are just some versions that you can talk to. So you can see what versions of the Python, DuckDB, and Pandas I'm using. Some helper functions to help us along the way. This is just a memory function which gives the current memory used, 61 MB. I'm using an M1 laptop, if anyone was curious. So a little bit about DuckDB. So DuckDB is an in-memory OLAP database. SQL execution engine. In memory means it's in your RAM. It's not a warehouse sitting somewhere else and you have to communicate it through a socket or anything like that. OLAP is online analytical processing as opposed to transaction processing. So OLAP is really good for doing large table scans, aggregation, and great for data, backend data processing work. It natively reads PyArrow and Pandas, R and Polars too. I'll talk about that in a minute. DuckDB also can be compiled to WASM. So that means you can run it in your browser, similar to PyScript. So it's great, it's pretty efficient, and you can do a lot of interesting stuff now that LLMs are around too. You can just get the SQL query and execute in your browser without moving the data out of your laptop. DuckDB can read Parquet, CSV, JSON, Iceberg, Delta as experimental. You can read data from your laptop via HTTPS or in any one of the popular cloud services. There are 3 ways you can, in Python, you need to create a connection object. There are 3 ways to do it. In memory, that is your RAM, that doesn't support out-of-core operations. If you need out-of-core operations, say you have 8 GB RAM, but your data is 16 GB, you can either provide a temporary storage path where the temporary storage will kind of not persist when you close your connection, or a persistent database location where the storage will be persisted even if you close your connection. Like I said, my motivation is to give you enough of an overview that you feel incentivized to take a look. So I'll go through this quickly so that we can focus more on the interesting part of scaling outside the warehouse. Let me just make sure I land these functions. Okay. DuckDB has some helpful ways of setting AWS. I'm just setting up the credentials here, which I'll be needing later. For this demo, I'll be using the New York taxi data set. It's pretty popular in demos. So created a helper function to get the path for the data. It's monthly data. It's via HTTPS and their Parquet files. So this function is just to get the path of the file. So in most of the times, I'm doing 2024 January to 2024 September files. So just to show you what the paths looks like, this is just 3 files. There are 9 files in total. One benefit of mixing Python with SQL is you can use Python's classes, function, for loops to help organize your SQL code much better instead of just having hundreds of lines of SQL code, right? So an example here, creating a Python function to read the Parquet file. So depending on the file that I'm passing, it's just going to do select star from read Parquet, and here are the files. So here's an example where the way you run a DuckDB is using the connection.sql. This is where I've set up the connection. Well, I'm using a persistent database, so it's just a path on your laptop. It can even be an S3 or your cloud services. And if the database doesn't exist, DuckDB will create that. So here you can see DuckDB has read that Parquet file via HTTPS, and I'm just showing you 10 rows. Yes, I'm going to quickly go over this. And then this time, this is just a backup. I'm creating the 9 files as tables. So these 9 months of data is 30 million rows and 20, just to give you a size of the data that we're doing. So let me show you other ways in which you can mix Python and SQL. As you know, I'm creating a helper function to aggregate data. So the index, the parameters is an input table and an index column. So here I'm getting total amount, total distance, and I'm calculating the average fare for that month. So by whatever the index is. So let me create a daily average fare query where I'm saying the index is the pickup date time is in a timestamp. So I'm casting it to date. So that's the pickup date. And this will generate a query, which will give you the average daily fare. Same thing monthly, just converting it to a year month string. Let me run that. So here you can see an example with base. I'm reading all the 9 files, then pickup date and aggregating it to average fare and grouping by getting the aggregation for total amount, total distance, and average fare. DuckDB is able to run this quite efficiently and quite quickly. And the same, let it go in the background. And the same I'm doing with monthly. So here, my main motivation is to show you how I'm mixing Python and SQL helps you better organize your code, makes it modular, helps you to debug and make changes easier rather than just using 100 lines of SQL code. Let me skip the statement. This is profiling statements. You can read more about this in the DuckDB documentation. The DuckDB site is awesome. The blog is really great. They have a lot of good tips on how you get the best out of DuckDB and even the internals. I would highly recommend DuckDB is based on a Postgres dialect, but they've rewritten the parser and the execution engine ground up. So they've made SQL, reinterpreted did some enhancements to SQL so that it's much more easier to use. So there are some great blogs by Alex Monahan, Friendly as SQL. I would highly recommend you check it out. And during the demo, I'll also highlight some of the Friendly as SQL methods that I'm showing. At the beginning, I said DuckDB natively reads pandas, polars, R, even PyArrow. What does that mean? Before DuckDB, whenever you had a SQL engine in Python, you would have, when you move from Python objects to a SQL, or say you had a pandas data frame and you had to execute SQL on that, you'd have to serialize it, send it over the socket to the SQL engine. There it will be deserialized, run the SQL statement, and do the round trip back to the pandas data frame. So there's a lot of overhead. With DuckDB, there's no more of that. DuckDB is the SQL engine in your RAM, and it can natively read pandas, polars, R, pyr objects. Let me show you an example. Here from the Seaborn library, I'm loading the iris data set. So clearly you can see this is a pandas data frame. And here I want to get a max of all columns. This is one of the examples of friendlier SQL that DuckDB has. So generally, if you want to get max of group by species, right? So this is the data. This is categorical variable species, and there are these numerical variables length and width for sepal and petal. That's a popular data set. You can check it out online. The general way to do it is you'd say select species and then you'd say max each column you want to do it. DuckDB has these columns function where you can, if you say column star, it gets all the columns that is there in the table. And you want all the columns except species. So instead of explicitly saying what columns you want, you can say column star excludes species, and then you can pass the max. So this literally replicates this function, and this is the friendliest SQL that DuckDB has. So I'm saying select species max of these, and I'm saying from iris data df. So iris df is a pandas data frame. It doesn't exist in the SQL world in this. DuckDB is aware of the Python namespace that is there in your environment. It looks for iris data frame and it directly reads the pandas object in memory rather than having to do serialization and deserialization. So that's awesome. You can say, hey, I'm more coming from the pandas world and I don't want to write all these select statements and string queries and pass it. DuckDB has an answer for that too. So for the Python specific API, there are two API, sets of API, relational API and functional API. So functional API, you can think about that as UDFs. Relational API is more what I'm going to demo right now. So let me create a DuckDB Python relational object saying select star from New York taxi. This is a table I created which has the 9 months of data, and you can convert it to dot. When you say the table dot df, it will convert a data frame. You can convert it to arrow. You can convert it to polars data frame, or you can even get it as a list of tuples. That's fine. You must be familiar with the pandas chaining method. You can do something like that in DuckDB too. So here's an example. You're passing the New York taxi table. It's still a SQL table. The relational API has some functions like projection, aggregation, join, intersect. So here you're saying aggregate pickup date time dot min, pickup date time dot max. This dot min and dot max is another example of friendlier SQL. Generally, when you want to do multiple functions on a variable, this is the way you would define function one variable and encapsulate it with function two. In DuckDB, you can do chaining operations like variable dot function one dot function two, which makes life easy as you can read it much more easier to read. One way I generally mix, Python and DuckDB is, especially if you have lot. In this case, this is 30 million rows. You can do all the transformation aggregation in DuckDB, but the plotting, machine learning part at the very end, you can, convert it to a pandas data frame, and from there, or a NumPy array, and from there, use your favorite Python package to do it. So let me show you an example here. I'm taking the New York taxi data, filtering based on date. This is the DuckDB Python relational API. I'm aggregating pickup date, total amount, total distance, calculating the average fare. I'm ordering by pickup date. And until here, it's all in SQL, DuckDB SQL. Then I'm doing .df, pandas, and then I'm passing it to Seaborn plotting to plot a line plot. So this is doing transformation on 30 million rows and in 0.27 seconds. So less than a second, you are doing the transformation and getting. So you can think about it when you're doing machine learning project, do all your joins, do all your transformations, feature engineering, finally converting pandas, then you can pipe in scikit-learn and do the modeling. In the interest of time, I'm just going to walk through this. So I've converted the table to DF. It takes about 26 seconds. And so far, I've used about 210 megabytes. When you convert it to pandas data frame, that's 4.1 GB. And the same thing on the New York pandas data frame of the New York taxi table, it takes about 21 seconds to run the same thing as opposed to 0.21 seconds. So I hope I've given you enough incentives to add DuckDB to your toolkit. I really I get the best of both worlds. I get the best of Python's, using functions, classes, loops, and other packages. But when it comes to data transformation, I pass it on to DuckDB and get it efficient. It uses multi-core, and that's awesome. Let me pause and let me say now I'm pivoting out to the main talk, scaling outside the warehouse. So scaling outside the warehouse, two sections. One, I'm going to demo using AWS Lambda, and then Coiled. I'll come to Coiled after this. So most of you know AWS Lambda. It's a serverless platform. It's scalable at any instance. You can run you can invoke 1,000 Lambda instances, and it can execute those Lambda instances in parallel. There are two ways in which you can invoke a Lambda instance. It's using event, which is synchronous. That is, every time you invoke, it will execute whatever the Lambda function. You'll have to wait until the result and then go to the next statement. Then there is asynchronous or parallel invocation, or you can event invoke it. That way, it'll just trigger the Lambda, and you can trigger 10, 20, 100,000 Lambda function calls one after the other, and all of them can execute in parallel, and finally, you can get the result. One way I use this is this way. Ideally, you have the data on the web or S3. You create a function task which based on a specific input can be day of week or day or month, and have a custom SQL query for that particular input and output, pass it to the AWS Lambda, let it all execute in parallel, and let it save it back to the S3 bucket, right? You don't want to get it to your laptop. You want the compute be closer to your storage. Let me explain more in detail about this. So first thing, you need a Lambda function. So this script has the Lambda function that is there. A few things I want to highlight is the input for the Lambda function. There's a query. So whatever query you give, DuckDB on that Lambda function will execute that query. And in our case, it's reading from S3 or the web, executing and storing it back to S3. I want to highlight some status log messages I'm putting so that we can track the status of every Lambda function call. So request ID, status is started, success, or error. So that's important to know. And it's in a format of a JSON string, right? Once you invoke the Lambda, CloudWatch using AWS CloudWatch logs, you can track all the events. That is, these are all the logs that we are eventing. So you can track the events. So for every request that you've invoked, you can know whether it's started, is it success, or it's a failure. This utility script has some scaffolding code which helps you do the invocation, get the CloudWatch logs, pass the CloudWatch logs, track the status, and an orchestration function. So let me quickly go over that. So this is the pattern that we have in the Lambda function. When you create the Lambda function, just put the query Lambda function name here, and this is the log group name. There are four major classes. This class invokes the Lambda. We are interested in this async invoke. Then this class does the CloudWatch log. So it gets the CloudWatch logs and passes the event. So in our case, we have success, started, error. And for each Lambda request ID, you track the status, whether it started, success, or error. And then this that is for a request ID level. Now you want to map it to your task. So every task has one-to-one mapping to the request ID. So this maps the status of the request to the task and summarize whether how many of your tasks have completed and how many have failed. And this class is just orchestrating everything. So it uses all the other classes above to invoke, to get the CloudWatch logs, to process the CloudWatch logs, to update the status, and wait until tasks complete. Let me show you a concrete demo. So in this case, just a helper function to do the daily average. We've passed. The only thing is, in this time, I'm copying the output to an S3 file. So whatever the output path is there, let me create a function to create tasks. So this is getting an input as months and output as S3 output base. So basically, for each month, I'm getting the input file, I'm getting the output file, and I'm creating the aggregation query. And for each month, I'm creating a task. Each task has query, month and output is more metadata. Query is the one that is important. And for each month, I'm creating a dictionary of tasks, right? So in this case, 9 months of data, my output is an S3 location. The input is the web HTTPS, the New York taxi data set. So 9 tasks, the month is the key. This is how a single task looks like. Copy, do get the daily average and write it to S3. Uh, so here I'm using the Lambda task class to get the Lambda invoice. I'm invoking the Lambda task. It takes a few seconds. And then I'm just going to say wait until task complete. Here I'm saying wait for 60 seconds, and every 3 seconds, check the status of the tasks. So it's running. It should be done in a few minutes. There, it checked, started 9 tasks, completed 9 tasks, and it's about 11.84 seconds, right? This is just getting a timestamps of the files that we just did. And this is reading the output of the daily average that we did. So now you're saying, okay, 9 months, I can do it in my laptop. But what if you have to do it for 60 months? What if each month is like 1 or 2 GB? And that's where scaling outside the warehouse. Traditionally, you would go to a traditional warehouse and you'd have to run it there. But now, because DuckDB is so lightweight, I think DuckDB installation is something like less than 20 or 30 MB. It fits well in Lambda. So now let me show you, I'm processing 60 months, started from 2019 to September 2024. Invoking 60 tasks. It takes a couple of seconds, and then the same thing, wait until task complete, and then let it run. In the interest of time, I'm just going to walk. It just keeps checking. Um, It'll see in the first iteration, 43 tasks started, 40 completed. After 3 seconds, it's checking. 57 tasks started, 56 completed, and then all 60 started and complete. So 9 tasks, about 11 seconds, 60 tasks, around 13 seconds. So even if you do 100 tasks, it should be around consistent time frame. That's the benefit of this. So Lambda has one limitation, that the max memory you can have is 10 GB and the max execution is 15 minutes. So if your input is, say, 20 GB or 30 GB or 60 GB, then Lambda might not work. So an alternative is you have to use an EC2 instance. But the challenge with EC2 instance, you have to start an EC2 instance, install your package, copy your code, run the code, and then stop the EC2 instance so that you don't get a big bill. And managing that is no easy task. That's where Coiled comes in. Coiled is a platform that helps orchestrates computing on the cloud. What Coil will do, it removes the friction from moving from your laptop to the cloud. So Coil will take care of starting an EC2 instance, replicate the Python environment in your local laptop on each of those EC2 instance, copy your code from your laptop and execute that in each EC2 instance. Once it's run, then shut down the EC2 instance. Coiled was also started by the creator of DAS, Matthew Rocklin. So they have a great team there. I've been using Coiled for close to a year and very impressed with them. There is some cost associated with it. Please take a look. I would highly recommend checking out Coil. It's like 0.05 cents per CPU hour. So first 10,000 CPU hours is free. After that, it's like 0.05 cents CPU hours. The example I gave you at the beginning, $1,000 in Snowflake versus $104, that is including the coiled cost. So coiled overall, using going straight to your cloud using EC2 or Lambda significantly reduces the cost. Coil can also, data scientists will love this. Coil can also spin up a EC2 instance, install Jupyter Notebook, and open a portal. And let me show you a demo. So here, this is my space, which has PyData global Python environments. And all I'm saying is Coil notebook start sync region. I want a machine with 8 GB RAM and idle time of 45 minutes. So if it's idle for 45 minutes, shut it down. Coil will start an EC2 instance, replicate my Python environment in this environment. On that EC2 instance, open Jupyter, install Jupyter, open a portal, do the tunneling, and do it on my browser. It'll take a minute or two. In the meantime, let me show you how you can also use it not only for notebook, but as a serverless function. So similar to how we had tasks, you just have to create, of course, install Coil. There's a whole setup to link your cloud account to Coil. You'll have to do that. I'm saying run Coil task. I'm creating that. And all I have to do is attach this decorator to that with some parameters, similar to what I showed. 8 GB RAM, use spot EC2 instance. If it's idle than 30 seconds, let me just run this in the meantime, and I can explain it to you. If it's idle for more than 30 seconds, then shut it down. So I'm creating a function run Coil task. It has an input. Input is a query. It runs the DuckDB SQL, and then it just returns true. That's it. So here I'm creating a task of same 9 months. Like we saw before, each task is query, month, and output. And here I'm saying Coil to, because I added the decorator, Coil has some enhancements to the function. Because I know I have 9 tasks, I want Coil to initiate all the 9 EC2 instance at the same time. So I'm just saying minimum is 9 EC2 instance, maximum is 9 EC2 instance, and the run Coil task function that I hear, and I say map, and I'm just passing the list of tasks that I have done. So coiled is, this is the EC2 instance cluster it created. Let me show you the infrastructure. It's still initiating there. It's spinned up all 9 spot instances, and in each of them, it's going to run this one. And this is coiled UI, and here you go. I added some metadata to print out when it's completed. And you see all the 9 tasks are completed. This is the demo. This is the Jupyter notebook that Coil started. So you can open it. So this is an 8 GB EC2 instance that Coil started with the demo. It has all the code that I have in this location, that I have all the scripts, and all the scripts are synced. Any changes I make here, they will be replicated in my local environment. So this is identical to this. So let me just show you. There is a code here. I'm uncommenting this and just running this. I'm saving it. I'll just say overwrite. And then I'm going to open my code. Let me just close this so that it refreshes. This is my local laptop VS Code. You can see that the change is there. So you don't need to do sync between your EC2 Jupyter notebook on the EC2 instance and your laptop. I know we are at time, so I hope this session was informative. Please check out the GitHub link and the slides, and I'll be on the Discord server if you have any questions.
Oh, thank you, everyone, so much for coming. And thank you again to our wonderful speaker. Hope to see you, and we'll be having a local PyData meetup soon, but I won't get into that. Everyone, please join the Discord to continue on and find a local chapter if you're around one. And you all have a wonderful day.
Thank you.